Hi everyone, in this video we are going to comment on what's happening when we apply a function on both sides of an inequality. So let's say we have f, a function, we have two numbers x1 and x2 just like this, and we want to know what's happening if we have to compare f of x1 and f of x2. Do we have necessarily f of x1 greater than f of x2 or the other way around? So that's the big question mark that this video tutorial is going to answer. Let's first start with the function f of x is x squared. So you can see the graph of this function right here. And let's have a look at one first example. So let's say if x1 is 1 and x2 is 2, you see that f of 1 is 1 and f of 2 is 4. So we have 1 is less than 2. See, 1 here is less than 2. F of 1 is 1, f of 2 is 4. 1 squared is 1, 2 squared is 4. And you see that f of 1 here is less than f of 2. So it looks like the function f can be applied to this inequality, and 1 is less than 2 is translated by f of 1 is less than f of 2 on that example. Let's now have a look what's happening on the negative side of the x-axis. You see that minus 1 squared is 1, and minus 2 squared is also 4. So what can we write here? Well, minus 2 is less than minus 1. See, minus 2 is less than minus 1. F of minus 2 being 4 and f of minus 1 being 1, you can write that f of minus 2 is greater than f of 1. So look, when we applied f here, we had to switch this inequality because here we have a 4 and here we have a 1. So here, you see, everything behaves in a different way than in our first example. Well, graphically, you do understand where it's coming from because this curve is going down, so the more on the right you get, so the greater x gets, basically, the lower f of x is getting. On the other hand, if your curve is going up, the more you go to the right, the upper you get when you apply your function. So what it looks like when we look at this example is that you are allowed to apply a function on an inequality without switching the sign if your function is going up, that is to say if the function is increasing, and you have to switch the inequality if you apply a function that is decreasing for your inequality. Let's now have a look at a few more comments to try and be a little bit more accurate about what we've just found out. Let's see what happens if we try to apply the function to minus 1 and 2. So minus 1 is less than 2, we have minus 1 here and 2 there. And so f of minus 1 is going to get smaller than f of 2. So the inequality here is not switched. But if we take minus 2 and 1 here, well, you see that f of minus 2 is 4 and f of 1 is 1. So minus 2 being less than 1, you need to switch the inequality when you apply the function. So here, you have to be aware of the fact that we can rely on the result that we've proved in the first part of this video, only if we apply the function on an interval on which the function is only increasing. So that was for the blue values of x right here in the first example, and the green values of x in the second one. But we basically can't pick one value from the green interval and one value for the blue interval, because then it becomes unpredictable, and sometimes you have to switch the inequality, and sometimes you can just leave it as it was. We need to talk about one last detail before we end this video tutorial. If we have a look at the graph of 1 over x, you see that this function is going down the whole way. You see, it's the graph is here strictly decreasing. So let's have a look at a few values corresponding to different x. So f of minus 1 is minus 1, f of minus 2 is minus half, f of 1 is 1, and f of 2 is half. Let's have a look at all these values. You see that minus 2 is smaller than minus 1. F of minus 2 is minus half, f of minus 1 is minus 1. So this value here is greater than this one. minus 2 is smaller than minus 1, minus half is greater than minus 1. It does make sense, our curve is going down, so we need to switch the inequality, the order of the numbers are reversed. Similarly, 1 is less than 2, and 1 is more than half. The curve was also going down, so we're inverting the order of the numbers. 1 is smaller than 2, f of 1 is greater than f of 2. Okay, now what's happening if we take one number on each of these branches? So you see that minus 1 is less than 1, and f of minus 1 being minus 1, it's also less than f of 1, which is 1. So you see that here, the function is decreasing, and you still can't apply the function if you compare minus 1 and 1. This is obviously due to the fact that you have some kind of jump in the curve here between the negative side and the positive side of the x-axis. So this is one more condition for our functions f that we apply into inequality that must be verified, and the function needs to be just drawn in one line. So we can have like two different parts of the curve, or at least on the interval on which we are using the function. So let's summarize a little bit what we've seen in this tutorial. If I have x1 smaller than x2, can I say something about f of x1 and f of x2? I can say some things under some conditions. These conditions are that f must be only increasing or only decreasing on an interval containing x1 and x2, and f must be continuous, means that there is no jump in the graph of f. The combination of these two here properties for our function makes our function 1, 1. We've given this function a specific name because they're extremely friendly, and we can apply them to inequality, and that's one of the good things about them. And so that's an important keyword to remember. These functions only increasing, only decreasing, and like nicely continuous are called 1, 1 function. So such a function, a 1, 1 function, can be applied to an inequality, and then two things can happen. Either f is increasing on the interval containing this x1 and this x2, then you can say that f of x1 is smaller than f of x2, so you can basically just apply your function here and there without changing the inequality. Or if f is decreasing on the interval containing this x1 and this x2, then f of x1 here is greater than f of x2, so you can apply f here and there if you switch the inequality sign. This is very important, and this will have many applications this year, so make sure you feel comfortable with this result.